Okay, this is eet114, uh, Introduction to Electrical Circuits number 2. And my name is Ron Kalin. I'll be your instructor for this course and for eet114. Today we're going to go over the syllabus. Uh, Let me share my screen real quick. Okay, so the syllabus looks like this. And this is going to be a web-based course, asynchronous. So we're not going to have a fixed time to meet each week. But what I'm going to do every week is give you an update on what the assignment is and any upcoming assignments that are due and future assignments that are due. For those of you that had me for 105, you know exactly what to expect. So here's my information right here. Here's my cell phone number and my email address. And my office hours. You can just text me for an appointment. So this class is, well, I'll tell you a little bit more about me for those of you that don't know me. So I'm an adjunct instructor. Here's my phone number and email. I have a Bachelor of Science, Electrical Engineering. Took some master's classes. I'm a professional engineer, PA licensed. I have 30 plus experience years as an engineer, electrical and mechanical. I currently work for Siemens Energy for 14 plus years. What I do there is I'm a project engineer for turbine and generator specialty services for large power plants and industrial plants and turbine and generator upgrades, repairs around the world. We do forced and planned outages. We support Siemens, Westinghouse, and all its Chalmers units. So this is, just basically power plant, mainly with turbines and somewhat with generators. Like they're going to be steam turbines or gas turbines mainly. We also support competitors' units. And my past employers in Mitsubishi Electric Consolidated Container Company and Elwood City Forge. I did a co-op program with ECF for 3 years when I was still in college. That's about it for me. As far as this course goes, this is going to be AC circuits primarily, uh, direct and alternating current analysis, including Thevenin and Norton theorems, mesh loop node, capacitance, inductance, resonance, power, and polyphase circuits. Your prerequisite is EET 105 or equivalent and Math 81. This is a web-based course, asynchronous, so no classroom or time slot is assigned. Most of the assignments will be taught by YouTube or Zoom video. This broadcast is going to be by both. I'm going to send you guys an email that has a link to Zoom and a link for the YouTube video in it. And it's going to be the same content, but probably primarily we're going to use YouTube. So each week there will be an update given by email with homework assigned from the textbook, and class sessions will be to watch the videos. I will consider in your final grade that you guys are watching the videos. I'll definitely know by the number of views that I see that you're watching them or not watching them. They're important to learn the content of this class. This is the only way really you're going to get to learn unless you ask me questions directly or we have a one-on-one session. Labs will be assigned most weeks, but not every week. And quizzes and exams will be given on Canvas. You can contact me for questions. Syllabus is subject to change. You guys, I'm sure, have seen that. The textbook is Introductory Circuit Analysis with Boylestad. Looks like this. I hope this shows up on here. It might not. Okay, this is what it looks like. It's blue, so it's not really showing up real well on here, but that's basically it. And it is required. I do post some of these, uh, the content of the book. The I post notes and I post the text on the book, and I also post PowerPoints that you can look at. Um, so you need the book, and it's also definitely required a calculator that can perform calculations on complex numbers. This is essential for this class. Absolutely. I have the TI-89. Looks like this. Okay. And I think I have a couple pictures of it that I can put onto Canvas. You need to get that calculator. I think you can pick one up for 25, 30 bucks. It's not expensive. It has to do complex numbers. If it can only do scientific calculations, it's not acceptable. Um, Access to an app that can do electrical circuit analysis is also required. Every circuit is what I prefer. I mean, you could use one of these two other ones, but this is definitely the preferred one. It's also $15. This is a lifetime subscription. It's $15 one time and that's it. So I'd really rather that you got every circuit. You're gonna need it to do the labs. To do the labs online, you absolutely have to get this program. And the app works on the computer, it works on the tablets, it works on the phone. It's very good and it's kept up to date. So you're going to need that app. You need to have a good understanding of algebra. This is a math intensive course. So, it's basically all math. You're going to be using a lot of math in this course. DC or AC analysis through series and parallel circuits is covered in EET 105. This class builds on EET 105. So um, you have to, you can't just take 105 and forget what you learned. We're going to be building on what we learned in 105. Some rudimentary computer literacy is helpful. Um, you need the internet as research. The goals are completion of the circuit sequence of the material begun in 105. So you're gonna by the end of this course have a firm grasp of AC and DC circuit analysis techniques following completion. And many of the topics that were only given cursory coverage in the previous course will be expanded on. EET contributes to the following outcome: an ability to apply knowledge, techniques, and skills of modern tools of their disciplines through electrical engineering technology activities, and the outcomes are using analytical methods, definition of capacitance and energy stored by a capacitor, AC/DC circuit analysis techniques, mesh and nodal analysis, network theorems, superposition, Thevenin and Norton, maximum power transfer, definition of the power triangle, watts, vars, and VA power factor correction, series and parallel resonance circuits with a quality factor, and then three-phase circuits, delta Y and all the combinations, non-sinusoidal circuits, Fourier series, and circuit response, and to use trigonometry, concepts, complex algebra, systems of equations and phasors to find solutions to electrical circuit problems. So I may do a quick review of the last few chapters we covered in EET 105, but it was basically the first half of the book we covered, chapters 1 through 12, and we're going to continue on with chapter 13, and we're going to go all the way to the end of the book. So we're going to go to chapter 13 through 26, and this is a breakdown of the content and roughly how long we're going to take to cover these things. It's roughly going to be about one chapter a week. Um, Major exams, quizzes, and reviews, about 8 hours. And then special topic, you will be required to do a term paper, and it will be weighted as one exam. Um, this course is concurrent to eet114, so I'm going to coordinate topics between the two of them. Typically, 118 is going to lag about a week behind 114. So every time we do a lab, it'll be, a week or maybe half a week behind 114, so it reinforces the material. The grading for this class, 3 exams plus a term paper plus a final, each weighted at 16%, 80% of the total. Homeworks and quizzes are each weighted at 10%, 20% total. And then participation is half plus half a letter grade, and demeanors and ethics violations minus half a letter grade minimum. This is the grading scale, which you all, I'm sure, are familiar with. I expect 100% attendance, meaning I want you guys to watch the videos and do the homework. It's very important to watch the videos and do the homework. I will drop the lowest single score in each category: test, quiz, and homework. In AET 118, I'll drop the lab at my discretion. The final exam and term paper will not be dropped. Again, attendance at each class watching videos is imperative to learn the material. Missed lessons require stated reason and make up work. Completing homework is essential to the learning process. Highest ethical behavior is expected at all times. Active participation is beneficial. And then here's my contact information. So to uh, to reiterate, um, I did a little study, and the study was on. Let me see here. Hold on a second. Okay, so here's a study that I did over the past 3 years, and it's showing overall score versus average homework score. I don't know if you can see this. I gotta make it bigger, I think. So there's this pretty strong correlation between the homework score and your total score. Even you guys might be thinking, ah, you know, it's only 10%. Who cares? Well, it matters because the way that I do the class, the quizzes and the exams are very integral and similar to the homework. Um, Homework is practice for the quiz is practice for the exams. So, with the exception of a few outliers, you know, you have a much greater chance. The R squared value is pretty high, almost zero point 0.7. So it's a pretty good correlation between homework score and overall score. So I really strongly encourage you to do the homework. Same thing with the labs. It's even stronger with the labs. You can see that it's 0.77, almost 0.78, that the correlation between your lab scores and your overall scores. Let me double check and make sure I'm recording here and sharing my screen with you guys. Nope. Okay, now it's recording. All right, so going back to the syllabus, um, the homework and lab report policy, homeworks and labs will be completed using answer forms in Canvas, and each student's own homework should be submitted in Canvas or a 0 grade will be given. So don't go into Canvas, fill out all the answers, and don't give me any handwork shown that shows that you're doing your own work. If you do that, or if you forget to do it, I'm going to give you a 0. I want you to submit in single PDF files. Late homeworks on labs, I'll give you 1 week's grace period. After that, I usually close them down. Will result in deducted grades and compounding deductions increasingly reduce credit will result for repeating offenses at the discretion of the instructor. Online labs will be performed individually using an app like every circuit, and each student will submit their own work online in MS Excel form. Those are for labs. Quizzes and exams, um, they're going to be held during a session that I stipulate. I'm probably going to give you a block of time to take a quiz or an exam on a specific day. They're going to be open book and notes primarily. I rarely do I say that you can't use open book and notes. That was always my policy. Online quizzes exams will be timed and require online answers to be completed in Canvas, so watch your time. Each student's own handwork must be posted in Canvas in a single PDF file immediately after the time is up, or 0 grade will be given. So all homework, labs, quizzes, and exams to follow the handwork expectations document. What is that? I have it posted. I have it posted in Canvas, but I'll go over it real quick with you. So here it is. This is handwork expectations, and this is all common sense, but again, not everybody's going to submit it, or you guys are going to forget, or you might give me something that I can't make out. So I have to give you these guidelines. Must be legible, clear, and readable. Must not be too light or too dark, too big or small. I have to be able to read it. Has to be written or typed with black or blue or pencil colored writing or font on white, black, or lined paper or background. I prefer you to print out a quiz or exam and fill it out. It just makes life easier on me and you. Having the proper header at the top of each page, including course number, assignment number, and name, student name, date, page number, and total number of pages. See this example. So this is an example of a header that I would put if I wrote it by hand at the top of each page. So this way nothing gets mixed up on my end, and you guys submit me the proper and complete handwork. Containing each problem has to contain all parts of the problem, i.e. the problem number from the text, quiz, test, or lab. Do not use the Canvas question number. Those question numbers don't mean anything to me. When I put the Canvas quiz together, it doesn't even number them until after I'm done. So if you say, hey, I had a problem with question 20, don't do that. Go to the quiz or the test or the homework or whatever, and tell me the problem number from there, and we could start from there. So that's this right here, this A. And then this is a redrawn circuit. If you need to redraw it, you redraw it by hand like this. This is this could be a homework, it could be a quiz, could be a test. And then the formula that needs to be used, you need to write the formula out. Okay, here's an example of a formula. I equals E divided by R. All right, you need to write that out. You need to show your work by putting the values in and showing what your equation is, and then solve it and put a box around it with the unit. Okay, like this RT has 7.4 ohms with a box around it, and this IS2 is a current, and it's 2.70 amps. All right, anything less than this example will have points deducted up to, including 0 credit for the problem, regardless of the correct answer is given. So I don't care if you go on Canvas and get 100% for a quiz or an exam. If you don't show me handwork that I can read and shows that you followed the process and you know what you're doing, you're going to get 0 for any of the problems, up to and including 0 for the whole assignment. This obviously does not include true and false multiple choice. If I give you true and false multiple choice, there is no work to be shown. But You could still write it down on your paper. And then what I'd like for you to do after you're done, scan into a multiple PDF file and then submit into Canvas as instructed. Do not send emails or PDFs or photos to my email. I use Adobe Scan on my phone. It's free. Here's a link to use Adobe Scan. And I also wrote out this procedure. It's very simple to put multiple scans into one file and then to send one PDF. I don't want you sending me 8 different pictures for, if an assignment is 8 pages long, I don't want you sending me 8 JPEGs or whatever. And, it just makes life harder on me to do that. And the reasons should be obvious. You're demonstrating that you know the material. You're making an effort to show that the work is coming from you. And it gives you a higher chance of getting the problem right because you're thinking through the problem and you can catch mistakes. And it allows for partial credit for me if an answer arrived at is wrong. If you have a math error or algebraic error or some, a value error, I can see that and I could give you partial credit. If you don't show me any handwork, I can't give you any credit. Um, you may have gotten the problem 99% correct, but you got the wrong answer. So I could still give you a lot of credit if you just made a small oversight. So, and then the rest of the syllabus is, it's just boilerplate stuff, attendance, and then all this other stuff. I'm not going to read it. This is boilerplate. It's standard verbiage, and you can read through it as you need to if it applies to you. And basically, that's it. So I'll be sending this link in an email. And again, welcome to this course. And there's not just going to be one video. There's going to be multiple videos. The next video is going to be showing you how to navigate through Canvas and the files that are going to be in there and what to expect with that. And I'm going to be doing the same thing for eet114. So that's it.